Let's look at some question of electricity Ohm's law. So here we're dealing with Ohm's law and we're calculating resistors in series. So resistors in series, you add them together. So how do you calculate this one? So you will say R1 equals to, let's say R total equals to R1 plus R2 plus R3. So you'll put the numbers here, 2 plus 5 plus 3. This is Ohm's law. So if a resistor in series, you add them together, and a resistor is a component that resisting. So 2 plus 5 plus 3 is 10. So using Ohm's law, so a resistor is a component that reduces the flow of current in a circuit. So if you have a circuit and there are resistors, so your current will be reduced at a certain amount. So the greater the resistor, the lesser the current to flow. So let's check number 2. So we have 2 resistors to the next one, and then you can add these 2 resistors because they are in series. Add them like this. Here let me remove the ohms. So you have something like 5 ohms. So this is how you calculate the resistor in series, and this one is also in series. So we use this step. So these are the small basics so that you have to understand some of the concepts of a resistor. So let's check the resistor in parallel. So these are the resistor in series. Check the parallel resistors. So when resistor in parallel and in series, they don't behave the same. The resistor in parallels, if they have the same resistor in series, let's take for instance you have similar resistor in series, like F6, 3, and say 3, 5, and then the same resistor, you put them in series. They will be different values. So if you calculate, so if you calculate the total resistance here, it will not be the same as the total resistance here. So the resistance that you'll find here in parallel resistance will be smaller than all of them. Let's take for instance here, let's write something like let's say it's 4 ohm all the way on. So and then if you put them, the total resistance in series and the total resistance in parallel, so which have the same value, they are identical. So the resistance that we'll find here, it will be bigger than all of them in series. And the resistor that you'll find here in parallel, it will be smaller than all of them. So let's calculate and see. Let me check the one that we adding this one in here, 4 plus 4 plus 4 plus 4, which is 12, which 12 is bigger than all of the resistors that are in series. So let's check the one that are in parallel resistor. So adding this one, so the equation of a parallel resistor is like this. So invert, and I have something like this to remove the one on top there. I'll put 4. So the resistance here will be smaller than all of them. So let's check with the calculator and see. Chicken. and divide by bracket 1/4 plus 1/4 plus so which is 4/3. So let's see what is 4/3. See, it's 1,3 ohms. So resistor in parallel, you always find it will be smaller than the smallest. A resistor in series, it will be bigger than the biggest. So if you can check this and see that, you see that this tells us if they are the same, the resistor goes like this, and so on. Like if we add can derive equation this one, continue adding this one, continue adding this one. So this one tells us there are 3 of them. So if you can continue add, that means the number of resistor in parallel, if they are the same, if only if they are the same, like if it's 4 continuously, you'll put the number of resistor here, and then if they say you have 6, you'll put 3 divided by 6. So we'll test on the next question. So but if they are not the same, it will be different story. We won't get the same answers as we will divide by 3. Divide by 3 because the number of resistors here, there are 3, 1, 2, 3. So that's why we say 4 divided by 3. So if there are 2, we'll divide by 2, like that. If only if they are the same resistor, they are identical, you can do this. But if it's not, you cannot do. Let's check the question now and apply this. For this one, there are a lot of pro equations or total. Can use this. You can use this formula. And let's note this one. Can use 1 or this one. So if you have identical resistance, you can use this one. And the resistor, and divide by the number of resistors there which are parallel. So, and the other one for this, if there are 2, you'll have a equation like this. And you can use the equation. This one can be R1 and this one be R2, so it depends which one you choose to be R1. So these are the sum of the equation that you can use if you have two resistors. So let's use that equation for identical resistor. You can have something like this: the resistor and the number of resistor. So you can say 6 divided by how many there are? 2, and means it's what? is 3 ohms. Let's prove using the other equation. And so we'll have 6 times 6 divided by 6 plus 6, which is equals to 36 over 12. So this one is for identical. If they are the same, have the same resist. So this one is for each and every one. So how many 12 here? There are 3. So we have total resistance as 3 ohms. So you can continue check using the other formulas, but you'll get the same answer. Let's check the next one, this one, and then this one you can use the same, this one. To calculate, so I prefer this one because they're identical resistor. You can just add the moment they are, you have 6 and they are 3. What is the answer? It's 2 ohms. So if you know this formula, it's easy to catch up with the exam time and easy to solve lot of questions. So the other one, the one for this one, for 3 resistor, let me try to make it okay. If you have 1 over plus 1 over r2 plus 1 over r3, and then this one, all of them, they will multiply together. This one, they will multiply all together. R1 R1 multiplied by R2 multiplied by 3 R3. So when you multiplication here, when you take this one and multiply this, you take the whole thing here, you multiply the one. This R will cancel this R, so we have something like R2 multiplied by R3. And same applies to this one. Take the whole thing, multiply by 1. So this R2 will cancel this R2, so we have something like R1 R3, and then this take it multiplied by the, you have something like R2 multiplied by R1. So inventing this one will have something like R total. Take the bottom part when you invert and put it on the top, so we'll have something like R2 multiplied by R. So you can see this is the space for R1 where there was R1, so we didn't put R1. So in R2 we won't put R2, we'll put R1 multiplied by R3. We didn't put R. When you check here, there's R2 and here we then put R2, so the R3 is not here where this R3. And you have something like so we have something like R R1 multiplied by R2 multiplied by R3 all divided by so this is how it's supposed to be. So this is the equation we'll use when you have three resistors, not identical, we'll use the same thing. So let's check for this. Oh, this answer that it was correct. Now the value of the answer that we got it from there, was it correct? So we have something like this, and 6 times 6 times 6, so this is R1, R2, R3. So here you have to multiply this one, 6 times 6 plus 6 times 6 plus 6 times 6. So what is the answer here? 6 times 6 times 6 equals to, so here we have 36 times 3, because 6 times 6 is 36, so we'll say 3 times 36. So we have something like see it's 2, so when you check here, the answer is 2 ohms. So you can group the equation as you started from that one, like that. And then that's it for resistors and series and parallel.